Hello Tech Zone students, how are you all? In this video we will learn about linear regression. Okay. Now, linear regression is the most basic statistical technique. Okay, it is the most basic technique and it is widely used in predictive analysis. It shows a relationship between independent variable x and dependent variable y. Now, what are these independent variable and dependent variable? See, let us say we have a data set in which we have only two columns. Okay, let me draw a sample database here, like years. Okay, years of experience or experience in years, and this is salary. Okay, let us say if somebody is having 2 years of experience, their salary is 35K. Okay, and if somebody is having 1 year of experience, let us say their salary is 30K, and if somebody is having 5 years of experience, their salary, let us say, is 45K. Okay, and so on. So this is a sample data set we have, right? Okay, now what is an independent variable and a dependent variable in this? Okay, let us say we want to build a model in which if we give years of experience, this model should give us expected salary. Okay, we will build a linear regression model. That model will predict the salary if we give years of experience as input. I hope this is clear. What are we giving as input? Years of experience as input, and that model will predict the salary. It will give us the salary as output. Okay, so in this case, what is an independent variable and what is a dependent variable? See, independent variable is the one which we give as input to our model. Okay, and dependent variable is the output. So in our case, this years of experience is our independent variable. So independent variables are generally denoted by X or capital X. Okay, dependent variables are generally denoted by Y. Okay, I hope this is clear. What is an independent variable? Independent variable or independent variables are the variables that we give as input to our model. Okay, and the model will give us dependent variable. In our case, years of experience is independent variable and dependent variable is salary. Okay, I hope that is clear. Now, if there is only one independent variable, then the linear regression is called as simple linear regression. Okay, so this is the example. We have one independent variable. What is that? Years of experience. Okay, so we have one independent variable, and based on that one independent variable, model will give us the predicted salary. So how many inputs are we giving? We are giving one input in this case. So such scenario, okay, is simple linear regression. Simple linear regression. If there are more than one independent variable, yes, we can have more than one independent variables also, then the linear regression is called as multiple linear regression. Okay, like, see, years of experience. Okay, and let us say GDP. Okay, that is the aggregate. Okay, aggregate in graduation, and let us say this is IQ. Okay, IQ of the candidate. Based on these three variables, based on these three independent variables, we will predict the salary. Okay, like if we give this three variables to our model, it will predict salary. So how many variables are we giving as input in this case? We are giving 3 variables. That is more than one variable, right? So this is an example of multiple linear regression. Okay, I hope this is clear. Simple linear regression will have one independent variable. Multiple linear regression will have more than one independent variable. Okay. Now, see, simple linear regression formula is y is equal to b0 plus b1x. Okay. This is the formula of simple linear regression. Don't get confused. We have seen this formula before. It's y is equal to mx plus c. We have seen this formula and used this formula in a different form like this, y is equal to mx plus c. The notation was different, right? See here we have y is equal to b1x plus b0. It is the same thing. Okay. Let us learn what these terms mean. What is y, what is b0, what is b1x. Okay. See, x is the value of the independent variable. Like we had years of experience, right? Years of experience. This is our x value. What is y value? Y value is the salary. This is our y value. Okay. So x is the value of the independent variable, y is the value of the dependent variable. Now b0 is a constant. It shows the value of y when the value of x is 0. See, this is the equation of a straight line. Okay, let us say we have x-axis and y-axis. Okay, this is the equation. This is a straight line. And let us say this is y is equal to b0 plus b1x. This is the equation of the straight line. Now, what is b0? b0 is this point. Okay, it is a constant. Alright, shows the value of y when the value of x is 0. If you substitute y is equal to 0 in this, sorry, x is equal to 0 in this, so this will be y is equal to like this, right? This is 0. So this whole term will become 0. We are left with only y is equal to b0. So when x is equal to 0, y will be equal to b0. Okay. So that is b0 or b0. Okay. This is called as y-intercept also. What is this called as? Y-intercept. Okay. That means where is our straight line touching y-axis? Our straight line is touching y-axis at b0 or b0. So b0 is our y-intercept. Okay. This one is y-intercept, b0. Now what is b1? What is b1? Let me clear the screen. Right. What is b1? See, it is the regression coefficient. It shows how much y changes for each unit change in y, x. See? Okay, what is b1? It is the regression coefficient. It shows how much y changes for each unit change in x. I'll explain you. See, let us say this is the value of x, x-axis, and this is y-axis, right? This is 1, 2, 3, 4, and here we have 1, 2, 3, 4, and so on. And we have a straight line like this. So what is this now? This is b0. So in our case, b0 is 1, right? Okay. Now, if we consider this point, let us say this point is 2, 2, right? And if we consider this point, this and this, what is this point? This is 4, 3. Okay. So see here, how much is y changing with respect to the change in x? Okay. That is the value of b1. We have learned this in high school. b1 is nothing but slope of the straight line. Okay. That is change in y divided by change in x. This is b1. So how much is y changing? Okay, if there is a change in x. Okay, so here how much is y changing? See, it was here, right? First the point was here and next the point is here. So how much is the change in y? 1 unit divided by how much is the change in x? How much is the change in x? First x point was here, right? Now it is here. So how much is the change? 2. So b1 will be 1 by 2 or 0.5. Okay, in simple terms, b1 is called as slope of the straight line. Okay, I hope the terms are clear. Y is dependent variable, b0 is y-intercept, b1 is the slope, and x is our independent variable. Okay, what our linear regression model does is it will calculate the values of b0 and b1. Okay, we will give the value of x, that is independent variable, right? Based on that we'll get the values of y. Okay, I hope that this is clear. I have a small example here. Okay, now this is our x and this is our y, independent variable, and the sales is dependent variable. What do we have in independent variables? Advertising dollars in thousands. So it is the money spent in advertising, and these are the sales in thousands. Okay, if we are spending $6,000 in advertising, we are getting a sales of 120,000. Okay, similarly, if you are spending 6.2, we are getting a sales of 130, and so on, right? So this is simple linear regression because we have one independent variable. Okay, based on that, in one independent variable, our model will predict the values of y, right? Okay, before that, what we'll do is we'll draw a scatter plot. We'll draw a scatter plot between the values of x and y, and if we do that, we'll get a graph like this. Okay, when we spend $6,000, see what is the sale? 120,000. Okay, and if you are spending 6.2, and if you are spending 6.2, it is around 130. Okay, I hope this is clear. Now what our model does is, when we are building a simple linear regression model or a linear regression model, what it does is, simple linear regression model will draw a straight line. Okay, straight line which is best fitting this data sets, which is best fitting these points, maybe like this. Okay, what is best fit? See, I have the same graph here one more time. Our model can draw a line like this, right? Or it can draw a line like this, or it can draw a line like this, or it can draw a line like this, right? We could have had any line, but we are saying that this is our best fit line. This line is our best fit line. Okay, now why is that? Because this line is trying to pass through all the points. Okay, see, I'll just erase the other points. First, let us go through this point. Let us first learn why is this line not our required line or not the best fit line. Okay, see, all the points that are on this line are our predicted values. Okay, so this is predicted values, right? Now see, when we are spending $6,000, the actual sale was how much? 120, but our model is predicting that it should be around 122 or 123. 122, let us take 122. I wrote that 122 here. Okay, so there is a slight error, right? There is a slight error. That is called as residual. Okay, what is a residual? Residual is the difference between actual value and the predicted value. This is our actual value, 120. What is the predicted value? 122. So what is residual here? actual value minus predicted value. Actual value is 120 minus predicted value is 122. So the residual is minus 2. Okay. So the difference here is minus 2. Okay. Let us study what the residual is for this one. Okay, this is 6.2, right? This was 6.2, and for 6.2 the actual value is how much? 130. But what is the predicted value? Our model is saying that it should be around 123. Okay, 123 is the predicted value. Now if you subtract this, this will give us 7, right? So 7 is the residual here. So this is 7. So like this, we will calculate the residuals of all the points. Okay, we'll calculate the residuals of all the points. Okay, and we square those residuals. Now why do we square those residuals? See, let us take the example of this 2 points only, these 2 residuals, 7 and minus 2. If we add this 7 with minus 2, we'll get plus 5, right? We'll get plus 5. Okay. Now this indicates that this 5 units is the difference, but this is wrong, isn't it? Okay, so to avoid that, what we do is we take the residuals and we square. So first it is 7 square. We take this residual 7 square plus minus 2 square. So this is minus 2. So this is 49 plus this is 4. So how much is this now? 53. Okay. But in doing this, what did we do? We have increased this number, right? We have changed the units. Like for example, the difference was what? Money, right? Like this is $120 minus $122. So this was minus $2, right? Similarly here, this was $7. So here we squared $7 and we squared minus $2. So if we square that, this amount 53 is in dollars square, right? This is dollars square. We have changed the units, right? So to bring back this dollar square to dollars, what we do is we will find the square root of this. Okay. I hope this is clear. Okay, we got 53 here. Okay. Now we calculate the residuals of only 2 points. We calculated the residuals, we squared, right? We need to find the mean also. That means we need to divide this by 2 now, because we are considering only 2 points here. We need to divide it by 2. How many points do we have here? 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. So we need to find the residuals of all 12 points, square, and then divide that number by 12. Okay. That number, whatever number we get, let us say after finding this, okay, after finding the squares and adding, let us say we got around 120, right? So 120 divided by 12 will give us 10. Okay, this 10 is our mean squared error. It is our, I'll write here, mean squared error. Okay, first we found the error, we squared, and then we found the mean. Okay, how many number of observations are there? Divide by those many number of observations, right? We'll get mean. So this is our MSE, mean squared error. But in doing this, in finding mean squared error, what we did is we squared these values, right? That means, see, this 120 was a dollar. See, this 120 is money, right? Let us consider that in dollars, and this 122 is also in dollars. So when you subtract $120 minus $122, we'll get minus $2. Same way, $130 minus $123 will give us $7, and we have squared those dollars, right? So this is $53 square, isn't it? And here also, when you divide this, this will be $10 square, but we need to find our value in terms of dollars, right? In the units of dollars, but we have squared those dollars here. So to bring back this squared dollars to square to dollars, so to bring back this dollar square to dollars, we will find the square root of this value. Okay, let us say square root of 10 is 3.2 and we'll have dollars here. Okay, so this is called as root mean squared error. Okay, we'll learn about this root mean squared error. Okay, I hope this is clear. Let me just clear the screen. Root mean squared error, also called as RMSE. The most common metric to evaluate linear regression model is RMSE. Okay, a high RMSE is bad for us and a low RMSE is good. Why is that? See, let us say these are our points, right? Okay, low RMSE means our predicted line or this regression line is passing or is very close to this observation points. Okay, if the point is very close to these observation points, the error will be less, right? Error will be less. Okay, the error will be less and square of that error will also be smaller, isn't it? And we'll find the mean and we'll find the square root of that. Alright, so this ideally RMSE should be a small number. Okay, it should not be high. That's why a high RMSE is bad for us and a low RMSE is good. Okay, this is the formula to calculate RMSE. So what are we doing here? This is the actual value. This y dash or y hat is predicted value. So we'll find the difference. Okay, yi minus y dash. Actual value minus predicted value. And we square that. Okay, just now we have learned why we square it, right? To negate that negative value. And what do? We find, like if this is first point and if this is second point, like this, second residual, and this is third residual, we square the residuals and we add the residuals, right? And then we divide by n. N is the number of observation points. So it is the same thing. Instead of writing plus and so many times, what are we doing? We are just generalizing this and writing it as summation. Summation I is equal to 1 to n, which means this we do n times because number of observations are n. And we find the mean. So when we are finding the mean, we need to divide it by the number of observations. So in this case, n is the number of observations, right? So we are dividing by n. That is only mean squared error. To find root mean squared error, we need to find the square root of this number. Okay. So a low RMSE is good for us. A high RMSE is bad for us. Okay. That was about simple linear regression. Okay. Now we'll go back to our Jupyter notebook. Now we'll go to our Jupyter notebook and write the code for simple linear regression. Okay. So first we'll import the libraries. All right. Import the required libraries. Okay. What are we using? We'll use NumPy as NP. Okay, we have imported NumPy as NP and import matplotlib. From matplotlib, we are importing pyplot as plt. Okay, and then we also need pandas as pd. I'll just execute this. Okay. So we are importing NumPy as NP and from matplotlib we are importing pyplot as plt and we are also importing pandas as pd. Okay. All right. So it is taking some time. Let us have some patience. All right. Now in the second cell, what we'll do is we'll import the data set. Okay. Now, what is the data set we are using today? I'll just show you. Okay. So this is our data set. We have years of experience, okay, and we have salary. If somebody is having 1.1 years of experience, salary is 39,343. If somebody is having 1.3 of years of experience, the salary is 46,205. Okay, so this is an example of simple linear regression. Okay, these are our x values, independent variables. Based on this years of experience will predict salary. Okay, our dependent variable. So I hope the data set is clear. You understood the data set. Let us import the data set. Okay, let us write it as data set. Data set is equal to pd.read_csv. Okay, and the name of the file is salary_data.csv. I'll execute this. Okay, now salary_data.csv is the file. Okay, this is the extension. Salary_data is the file name. .csv is the extension of the file, and we are storing that data set in our variable name data set. Okay, let us go ahead and print data set. And execute that. So see here, this is our data set. Okay, I hope this is clear. Now, so how many lines do we have? We have 30 data points. Okay, 30 data points. All right. Now what do we do is, we will separate the values of x and y. Okay, separate the values of x and y. Okay, and let us store the values of x in x only. X dataset dot ilog. Okay, so colon comma. So what does this colon comma means? Colon comma means we need all the rows, we need all the 30 rows. So see, we don't have 29 rows, it is starting from 0, right? See, we are starting from 0, 1 2 3 4 5, right? So till 29. So how many data sets we have, data points we have 30. We have 30 data points. Okay, so we need all those 30 data points. Okay, and how many columns do we need? We need all the columns except the last one. Okay, I'm sure you are familiar with this notation. See, we can write this salary as, this is -1, this is -2 if we are counting from the back, if you are considering the data set from the end, right? Columns from the end. This is -1, this is -2. We need everything except -1. That means we don't need salary in the value of x, because x is our independent variable, right? Okay, all right, so we save that in the value of x. Okay, what about the value of y? See, generally we take the value of x, we write the value of x as capital and we write the value of y as small. Dataset dot ilog. Okay, here also we need all the columns, comma 1, but sorry, all the rows. Here also we need all the rows and we need only one column. Okay, that is the value of y. All right, I'll execute this. Let us print the value of x. See, in the value of x we got only years of experience, right? Let us see what do we have in the value of y. In the value of y we got only the salary, 39,343 and so on. Okay, this is the salary. Now let us draw a plot between this x and y. Let us see what is the relationship between this. So plotting x and y. Okay, we'll draw a scatter plot. Plt dot scatter x comma y, and let the points be in red color. Okay, so see here, this is our graph. So see here, our data points are sort of linear, right? That means, see, we can draw a straight line like this. I'll just show you. We can have a straight line like this, right? A best fit line can look like this, because this data is distributed in linear fashion, right? Linear, or it is sort of linear. All right. Okay. So that is the reason why we are using linear regression here. Okay. All right. Now what we'll do is, we'll split the data set. Okay, we'll split the data set into training and testing. Now, why are we doing that? Let me explain you here. Let us say this is our data set. Okay, here we'll have the value of x, and here we'll have the value of y. Independent variable is x, dependent variable is y. Okay, we split this into 4 parts. Okay, we split this into 4 parts. This part is called as x training or x train. This is y train or y training part. Okay, and this part is x test, and this part is y test. Okay, so what we do is, we feed x values, this x training values and y training values, to our model. Our model will learn from this. Okay, so in training phase, what do? We give x values and we give y values to our model. Okay, we feed x values and we feed y values. That means we are giving the questions and we are also giving the answers to the questions. Okay, so our model will create a straight line. Okay, now in testing phase, what we do is, we give only the values of x test. Okay, and our model will predict y values. Let us say here it was 30, here it was 40, here it was 50, and our predicted values are, let us say, 27, 41 and 52. So these are our original values, and these are the values predicted by the models. So we compare this. So here it is 30, here it is minus 27. Okay, what is the difference? 3. Here it is 40, here it is 41. What is the difference? 1. 50 and 52. What is the difference? 2. So what do we do to this difference? We will square this difference. We will add, right? 9 plus 1 plus 4, and we'll find the mean. All right. So this will become 14 by 3, and we will find the square root of that. So that is root mean squared error, isn't it? I hope you understood this. Alright, so let us go ahead and try to split, and let us go ahead and split our data set in training and testing. Okay, so for that we need to import model selection from sklearn. Okay, model underscore selection. So from sklearn.model underscore selection, we are importing train test split. Okay, so x train, okay, x test, y train, comma, y test will be equal to train test split. So this method train test split, what it will do is it will split the values of x and y. Okay, it will split the values of x and y in 4 parts: x train, x test, y train, y test. Okay, and we need to give the test size. Okay, test underscore size should be equal to 20%. Let us give 20%. So 20% will be like 0.2. Okay, comma. So test size is 0.2. That means 20%, which means train size is 80%. That is 0.8, isn't it? Now random underscore state is equal to 0. Now what is this random underscore state? See, random underscore state, what does it do is, whenever we are running this model, this random underscore state equal to 0 will make sure that only the selected columns, selected rows, the same rows are selected randomly. Okay, I'll go ahead and execute this. Right, let us go ahead and just check what is there in xtrain. So see here, these are the values in xtrain. Okay, so it has selected randomly. Okay, now if you give random state is equal to 1, you will get same number of rows here but different rows, right? Same number of rows but different rows. So if you keep random state is equal to 0, every time you will get the same rows. Okay, so this is our xtrain. Okay, let us go ahead and print y train also. These are the values of y train. Okay, x test, capital X, x test. Okay, so how many 6 points are in x test? We have a very small database, data set actually. So this is y test. Okay, all right. Okay, what we'll do now is we will initialize our model. Okay, we are going to use linear regression, right? So what we'll do is from sklearn, okay, linear underscore model, we will import linear regression. Okay, what are we doing? We are importing linear regression. Okay, from linear underscore model. This linear underscore model is in sklearn. All right, and we are initializing this, initializing the model. Linear regression. Okay, using the variable regressor. We are initializing the model using the variable regressor, right? Now what we'll do is we'll feed the values of x train and y train to our model. That means we are showing the values of x train and y train. Okay, regressor dot fit, or we say we are fitting the values x train comma y train. All right. Okay, now what we'll do is we'll predict the values. Okay, let us store those values in y predict, y predict, regressor dot predict. This predict method, in this predict method will pass only the values of x test values. So when we are passing the values of x test, it will, this regressor model or linear regression model will predict the values, and those values will be stored in y underscore pred. Okay, let us go ahead and execute this y underscore pred. Let us print those values. So these are our predicted values, right? Let us go ahead and see here y test. So we have on the same screen here, right? So see, 37,731 is the actual value. What did our model predict? It predicted this number 40,748. There is a slight error, right? Of course, see, no model will be 100% accurate. Okay, the second value is this 1,22,391. So the second value was predicted like this 122,699, very close, right? And so on. See, you check all these values. 6 values are predicted. Okay, so these are the actual values, but these are the predicted values. So what do? Tell me. We find the differences. The first value will the first two values will subtract. Okay, y1 minus y hat, and we square. Okay, like this. I is equal to 1 to 6, because we have how many points here? 6. And then we find the mean of this. So that will become mean squared error. But we need to find the square root also, right? So root mean squared error. So this value should be small. Okay, we'll go ahead and do that also. Let us write that in code as well. Okay. I hope this is clear. So we have studied that the formula for linear regression or simple linear regression is this, right? So when we give the values of x, we'll get the value of y, and these two values b0 and b1 are calculated by our linear regression model, isn't it? Let us go ahead and find what our coefficients are. These are actually coefficients, right? Okay. Like, see, if we have x and y value, this is our b0, right? Y-intercept. And b1 is the slope of this line. b1 is the slope of this line. Okay. Let us go ahead and find what are y-intercept and slope is. Okay, so to do that, we'll use regressor underscore coefficient, regressor dot coef underscore. Okay, so this is our coefficient. Okay, and let us go ahead and also find intercept. Regressor dot intercept underscore. Okay, this is our intercept. Okay, see, which means y is equal to, see, this was b0 plus b1 x, right? So our model has given us this function or this hypothesis, right, where b0 is the intercept. That means this one, this value 26780 point something. Okay, plus b1 is 9312, this 9312.5 multiplied the value of x. This is our hypothesis function, right? So when we give the value of x, okay, that x will be multiplied by 9312.5 and this number 26780 will be added and we'll get the value of y. Okay, let us go ahead and write one example here. Let us go ahead and find one example. Okay, what we'll do is regressor dot predict. Let us predict what will be the salary if someone is having 4 years of experience. Okay, so see here, this is the salary. When you are having 4 years of experience, our model is telling that the salary should be 64,030. Okay, don't worry about this, these are just warnings. Okay, I hope this is clear. Now what we'll do is we'll go ahead and find root mean squared error. We can also find mean squared error, but we'll go ahead and find root mean squared error. Okay, remember root mean squared error should be small. Okay, for that we need to import few libraries. Let us import math first. Import math, and from sklearn.metrics we will import mean squared error. Okay, we will import mean squared error. Mean okay, sorry, spelling was wrong. Mean UARD, mean squared error. Okay, let us write mean squared error is equal to mean squared error, okay, of y underscore test comma y underscore predict. We are finding mean squared error of y predict and y test, and we are storing that in MSE. Okay, okay, spelling mistake again, my bad. SQUARD squared, right? Okay, all right. Now let us find root mean squared error. What is root mean squared error? We need to find the square root of this MSE, right? Isn't it? So for that we have imported math.sqrt will find the square root of MSE. Okay, let us go ahead and print RMSE. Wait, sorry, RMSE. Okay, 1 second. Let us go ahead and write here. Actually, it should be the code. See, it came as markdown, right? Let us write this as code. RMSE. So this is our root mean squared error. Okay, don't think, see, this is not a big number. We are dealing in thousands, right? So 3580. Okay, root mean squared error is actually small, so our model is doing well, in fact. All right, so that was about simple linear regression. We'll also learn about multiple linear regression.